Hello, everyone, and welcome to today's exciting virtual panel discussion. I'm Tim Stark and the host of today's exciting event. I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. This is our 15th and last webinar of 2020, and we are already scheduling our exciting webinars for 2021, which will be released soon. During today's webinar, we welcome questions and comments which can be typed into the questions box in the control panel. You may send in your questions at any time during the presentation and discussion, and our speakers will address them as we move through the discussion. The recording of this webinar will be made available on the FGI website after today's presentation. PDH certificates will be sent automatically to all who attend the entire panel discussion. Okay, today we have 5 distinguished panelists to answer your questions about subgrade preparation and CQC/CQA procedures related to the installation of geosynthetics. Like a building, a good geosynthetics installation and long-term performance starts with a good foundation or subgrade. I'll introduce each panelist and they will give a short description of the importance of a good subgrade and their task and thoughts for a good geosynthetics installation. Afterwards, the panelists will start answering your questions that you submit through the questions box. Our first panelist is Kennedy Garber, Vice President of Construction for Hallaton Environmental Linings in Maryland, and Kennedy will describe the importance of subgrade preparation on geomembrane installation. Kennedy, thanks for joining us.
Hey, thanks for having me. I'm on the installer side, so from the installer standpoint, I think it's important that everybody understands that there's a direct correlation between the quality of the subgrade and the overall quality of the installation, the performance of the project. So that's really what we want to sort of impress upon.
Great, thank you. Our next panelist is John Allen. John is a technical service manager with Owens Corning and also the president-elect of the North American chapter of the International Geosynthetics Society. John will describe the importance of subgrade preparation on geomembrane performance.
When I arrive at the site, you often don't always know the card you're going to get dealt or what your product's going to experience. And so in terms of QC and CQA actions, I'm always looking for the soil types that I have to work with and the tools that the contractors brought to the site to build the best possible subgrade going forward to ensure the quality of that membrane that's going down and subsequent layers that go above it.
Thanks, John. Our next panelist is Dave McLaury. Dave is the president and CEO of Demtech Services, Inc., which is a large manufacturer of geomembrane seaming and testing equipment since 1987. Dave will describe the importance of subgrade preparation on geomembrane welding and testing.
Thanks, Doc, and thanks everybody that's attending the webinar. The seaming of the geomembranes as it relates to subgrade and the quality of the subgrade sometimes gets overlooked, not by the installer, but a lot of times by the engineers, the dirt work subcontractors, the general contractors. So it's really important that when you want to create a good seam, it has to be free of certain elements like dirt, moisture, that sort of thing. And if the subgrade has low spots and standing water, for instance, that's a good one. Mud, loose soil, sand, it really can create a problem with seaming, which of course hurts the overall installation and its ability to hold whatever liquid you're trying to keep inside of there.
Thanks, Dave. Our next panelist is Brian Baille. Brian is the commercial director for TenCate's Environmental Infrastructure Group, and he will describe the use of geotextiles to protect the geomembrane from the subgrade and overlying materials. Brian?
All right, hello. So yes, my group will be engaged for protection, liner protection. So we'll look at various site issues that might be there that would engage the liner, and then also any structural needs that might be required to support the lining system. So it's really about protecting and supporting that lining system for the long term. So that's
Great.
where we come in.
Great. Our final panelist is Matt Kemnitz. Matt is the president of Leak Location Services, Inc., which surveys the completed installation to locate the effects of a bad subgrade on the geosynthetics. Matt will describe the role of subgrade preparation and defects in the overlying geomembrane. So Matt, thanks for joining us.
Thank you. So when we go out to a site, very rarely do we get to see the subgrade to know what it looks like, because we're the last step in this whole process. So how it affects us greatly is that if the subgrade is not smooth, there could be low points to where there's not intimate contact with the liner to the subgrade, leaving air pockets which are not easily detectable, to find leaks on those. And another situation is if the subgrade is uneven, it could cause some wrinkles, which again, when there's an overlap on the liner, that also is hard to find wrinkles as well. But we don't know that, we can't see it, so we do our best to find the leaks and hope that the people before us did the best job they could.
Great, thanks, Matt. So let me go to the next slide. Okay, so we already have some questions coming in. Please enter your questions via the questions box, and we will get through them through the panel discussion. So first question for the panelists. What are the 3 most common and costly subgrade preparation issues, and how do you prevent them? So who wants to start on that one?
Well, I'll start, Tim, if you don't mind.
Sure.
I mean, I think one of the most expensive parts of the job is the material. I mean, a lot of times it's 80% of the cost of our contract. So, you know, you got to take very good care of it, and you've got to be careful not to waste it. You know, as the installer, we don't buy too much because we don't want to work that into the job. We also can't afford to be short. So subgrade prep, having, you know, the right subgrade so that we're not yanking a piece of liner out and having to throw it away or repair stuff down the road is really a costly mistake.
Okay, and then, okay, John, do you want to, because there was a second part, how do we prevent the 3 costly subgrade preparation issues?
You don't let the water truck driver go home on the weekend. If you're working with clay, you got to keep the clay hydrated, and you can't let it desiccate, right? That's a well-known one. The second one are surprises in your soil conditions, and being able to accommodate that and work up front early. And if you need a cushion textile, you can go down that path to protect the membrane if this particle size is if you're oversized or if your particles are too sharp.
Okay. Anybody else?
I'll throw in a little bit, you know, in the subgrade, if there is a lot of sharp rock that hasn't been screened out, you can find literally hundreds of leaks in small 1-acre ponds. And if you have 100 leaks in a 1-acre pond, you pretty much, like Kennedy said earlier, you're gonna have to scrap it because it's just not worth it. So screening it, putting down a fabric, that all helps to minimize the damage.
Yeah. But if you had to break it down to 3, it would probably be what? Water, grading, and sharp objects, rocks, and other things. Those would be probably the big 3 on site prep.
Okay. Couple comments from some of our attendees. If you could just sort of wave when you jump in to talk, say they'll be able to identify who's talking. Okay, next question. Can you describe real life examples when you encounter issues with the subgrade, and how do you fix them? So let me be specific. Kennedy, you're the installer, so raise your hand and you start off.
Well, the first thing we're going to do before we start laying any fabric, geotextile or liner, is we're going to walk the subgrade with the contractor. If there's an inspector, we're going to walk it with the inspector, make sure that we understand what the expectations are and that everybody else does as well. We're going to do some rock picking, looking for any sharp objects. A lot of times you're going to see some rocks or roots or some material in the soil. Anything like that needs to be picked out of the surface. Also water. I mean, what Brian was saying here a minute ago, that water is a big killer. So, it's funny, a lot of times the first question we get when we show up to a job is, how much water can you weld through? The answer is none. So we don't want any water in there. A couple of soft spots we might be able to work around, but water is a killer for sure.
And there's some tricks to get around that too. It also depends, I say with Demtech, on what the liner, if you have a layer of geosynthetics under the liner, like a GCL for instance, or a geotextile as a cushion layer, that affords you a little bit more latitude on the subgrade, but still a good subgrade is super important from the word go on a quality engineered installation. There's tricks around it also with the welding side. If you do have a loose subgrade, sand, gravel, that sort of thing, you can use a strip of geomembrane underneath the seam area and pull that along as you go as a sled, call it a rub sheet, that can keep the welder up out of the dirt and the mud and the sand and the gravel and facilitate a good seam that way. But like Matt mentioned, if the subgrade is so bad that it's poking holes in the liner, then the quality of the seams are kind of a moot point.
Okay. Next question. What is the steepest slope you have ever seen for a liner system, and what additional considerations and concerns are there for that slope subgrade?
Kennedy, I would say that it comes down to the application. We do a lot of different types of containment projects. If we're talking a wastewater lagoon or a pond versus a landfill or some sort of secondary containment area, you have to factor in the steepness of the slopes with the length of the slopes. So if it's a containment area around a above ground storage tank, a 1-to-1 slope isn't a killer. But if it's on a pond, you're going to have slope, soil stability issues underneath the liner, with the, some water wave action hitting the liner. So you've got to sort of factor that into what your application is there. It's not just a one size fits all.
Okay. Anybody else with a steep slope? Yeah, go ahead, John.
So I've worked on I don't want to call it a tailings dam. It was a leachate collection dam downstream of a dry stack tailings impoundment that had near vertical on the side slopes to batten strip tie-ins, and then all of the soils were granular with chiseled rock anchor trenches. It's probably the hardest subgrade I've ever worked on, and the resolution was to go with a very thick liner, and then there was no fill placed over the top of it. But the real hazard actually was coming from above, outside of the work area, where there was a vertical face above one side of the dam area where you could have loose rock falling onto the liner. So point being, sometimes it's not your subgrade. Sometimes it may be hazards outside of the lining area that you need to consider a little bit as well.
Yep. Okay. Next, would a GCL be a better alternative than a geotextile if you have an unsuitable subgrade under the geomembrane? I don't know, maybe John and Brian?
Yeah.
You want this one, Brian?
Well, I think it's really kind of two different things. And you guys can correct me if I'm wrong, but I mean, a GCL is really a secondary, or in some instances, a primary source of lining, right? Whereas a non-woven, what we provide as a protection or cushion, it's really two different animals. So they shouldn't be confused. You're not really using a GCL as a cushion or as a safety device for cushioning, although you could probably argue that it does provide possibly, you know, some of that function, but that's not its primary function. Whereas with a nonwoven, that is the primary function, is basically to act as a protective layer. So not to mention some of the other functions as far as water transmissivity, maybe even air transmissivity. You know, none of those are within the GCL's, I guess, benefit, what it provides.
Okay. Next is, who has primary responsibility for approving the subgrade? Contractor, engineer, installer, regulatory person? Oh, Kenny, maybe you should start with this one.
Yeah, so there is certainly a professional responsibility on Hallaton, on the installer. However, you know, we're sort of limited to what, you know, what we can do. I mean, the contractor is going to provide a subgrade that's within the project specifications. We're there to say that we can or can't approve the subgrade based on what we think would be functional. Okay, so we can say, you know, we need some rocks picked or we need things dried up, but we don't necessarily approve the subgrade in terms of comparing it to the specs. We would really lean on the inspector, like a third-party inspector, the engineer representative, to be the eyes and ears of the client. So, you know, they would be out there during construction, during site prep. They would report issues, you know, they would bring up concerns with their client. And then when we get out there, you know, our job is sort of understand the needs of the client, you know, talk to the inspector about it, talk to the contractor about it, you know, and is it suitable enough for us to deploy the liner on?
Okay. Anybody else want to weigh in on that? Go ahead, John.
I'll weigh in on that. Kennedy touched on the specifications or the contract documents that everyone's held to. Not every project has every layer or every belt and suspender option that's out there. So in some cases, the membrane will go down, and it's probably at the discretion of the installer. And in other places, you'll have multiple levels of different approvers of that subgrade. So it's dependent on project risk, contract documents, and just what you're building in general.
So is it the CQA or the third party that's really approving it then? Who actually gives the approval and says it meets spec?
Well, I suppose that but what John's saying is that if there is a CQA on site, I mean, the CQA is the client's eyes and ears, you know, and they're going to be reporting this back to their client. But in a lot of cases, there's not a CQA on site. So in those cases, it would be the installer that would have we'd be approving it or rejecting it based on what we see. And we'd be, you know, sort of relaying our expectations to the client, to the contractor, on how much risk we're willing to take and the correlation between, you know, the subgrade preparation and what we're going to get out of the end of it. We wouldn't accept anything that would jeopardize the quality of the liner.
Okay. Should whoever's going to approve the subgrade be formalized on each day? In other words, have like a pre-meeting or a start the day. Who is going to be approving subgrade?
This is Kennedy. I lost my connection, but I can still hear you guys on my phone. We would approve it each day. So we would walk the area that we plan on covering with liner every day before we start. And even after lunch, basically between each shift, you know, we would inspect the area in front of the liner that we're laying. If we have any issues, we'd bring it up immediately for repair. And assuming it looks good, then we'll commence with the installation.
Okay. The questions are really rolling in now. So I have a question about interface transmissivity. I realize that the geotextile beneath the geomembrane will act as a conduit for leakage through any holes, but this geotextile could also prevent holes. How do you balance these two conflicting things? So in other words, the idea is the composite liner, the geomembrane's in intimate contact with the subgrade. So if we put a non-woven, for example, Brian, so I'm going to pitch this to you.
Yeah.
Do we lose our composite liner action?
Well, I mean, and I've seen in a lot of specs where they'll actually have some type of permeability or transmissivity value to the non-woven under the liner. But I think ultimately the intent is to never have that happen. And I don't think the intent of the non-woven is to place something in there that provides really good transmissivity for toxic leakage underneath the lining system. I think it's really for more groundwater movement. I would assume, basically water movement coming from underneath the liner and creating a conduit or a way of allowing that water pressure to dissipate from underneath the lining system. I don't think it's viewed in terms of allowing leachate a conduit for getting out of the system. That's not the intent of the non-woven. It's really protection and to mitigate that from even happening. So I think, did I answer the question there, Tim? I think that's what they were looking at, right? The contradiction between those two.
Yeah, I think so. And I think your point about specifying the transmissivity of the geotextile, if you're worried about that, keep it very low.
Yeah.
So there's not a conduit there. Okay.
Yeah. And I think ultimately I see a lot of specs where it's in there, but after you have a quick conversation with the engineers, it quickly becomes apparent that really it's a non-factor. What you're looking at mainly for the non-woven is protection. So cushioning, protection, water movement is really not high, if at all, on the list of things that should be viewed for that material and that application.
So ahead, Brian, on that note too, like if you're having to use a textile under the liner, usually you're dealing with a cohesionless soil, which is going to be highly permeable anyways. Yeah. So it's not an inhibitor of more flow because you already have a high flow situation underneath your liner to start with.
Right.
Okay, next one is really steps into it, and maybe we'll just go around the room on this one. What size rocks are acceptable under the membrane? Would you allow larger rocks under a GCL? So I don't know, Kennedy, why don't we start with you? And I think this can go to everybody and end up with Matt about what size rocks he usually sees with defects. So think about that one, Matt. Go ahead, Kennedy.
That's a good question. So it's not necessarily, we don't want to see a lot of rocks in the subgrade, I guess, to kind of answer the question. Less than 3/8 minus is you see a lot of that in spec books. But for us, the important part is what's rolling up on the surface. So we're going to be pulling geotextile, GCL, geomembrane out directly over the soil. And if everything's rolled in nice and tight where we're not rolling those objects up and creating a sharp point, the fact that it's in the subgrade isn't necessarily the risk. It's unearthing it and creating an irregularity in the surface, and that's what's going to create a puncture point for us. So we might see some grades that are all rock. I mean, they're rolled in really nice, and we just have to deal with what we have. Given a situation, maybe a secondary containment area, but as long as the rocks are rolled in nice and tight and they're not showing up into a point where they're going to punch a hole, then it's something we can live with. But I guess the short answer is the fewer rocks, the better.
John?
So from a manufacturer perspective, I don't think you'll find a manufacturing installation guide out there that doesn't give you a maximum particle size. And that's always going to be the manufacturer's position. When it comes to actual construction, like Kennedy was describing, and you do have max particles, or your borrow source investigation reveals that you're just going to exceed that all the time, there's a process that you can follow to evaluate textiles for the puncture protection that you need. And then that's when you start deferring and calling Brian, is to get that support. But yeah, max particle size is very well defined by the manufacturing community and what they'll allow in the subgrade.
Demo, Dave, any rock size issues getting welders?
Yeah, as it results to weld quality, not really. I mean, if we're talking about a GCL being present underneath the geomembrane, then that basically separates the subgrade from the seaming area, from the geomembrane seam zone. So there's really, there could be very large rocks under there, unless they're sticking up several inches where they create a barrier or enough friction on the welder itself to try to stop the machine in the seam, which that obviously would have been taken care of before that point. Then there's really no big issue there. It's when there isn't something underneath the liner and the machine has to travel partly on the subgrade itself, directly on the subgrade, is when we have concerns with the quality of the subgrade itself.
Okay. Brian, anything else you want to add on geotextile and maximum particle size?
Not really. I mean, they pretty much touched on it. It's really what the liner, it's really based on the lining manufacturers and what they see as being limitations, particle size limitations. And I would assume that the type of particle probably has a little something to do with it also, the shape or the angularity or anything like that. But as far as with the non-wovens, I think they're really added in as a kind of a belt and suspenders, just to add further protection for lining systems. So.
Okay. So Matt, again, we started with particle size, but I've got a bunch of questions here about leak location. And for example, any rule of thumb of where you see most damage versus maximum particle size? Is there a relationship between particle size and number of defects? So I got a lot of questions about those topics.
So where we see most of our damage, if I had to break it out, would be at the toe of slope. And it's not really the size of the particle or the rock in this case, it's the sharpness of it. So if there's a sharp rocks in the subgrade, those will work their way through. It does make me feel good though when I go out there and I see a fabric down or a GCL down. I know there's some protection against that. I mean, if we could find manufacturer pinholes in the liner, then any size, as long as it's sharp enough to puncture the liner, we're gonna see it. So that's where we see most of ours though, is the toe of slope in that area. Anywhere there's a lot of welding going on, a kind of a difficult spot, maybe even a pipe boot. Those are tough to do. Never done one myself, but those are where a lot of leaks are showing up too.
Okay. All right, here's another one. Some engineers and owners are hesitant to dictate means and methods for the earthwork contractor to prepare the subgrade. In our CQA function, have found it critical to get a good subgrade requires the specs to dictate means and methods. Has the group seen a project where detailed subgrade specs other than smooth and free of 1/2 inch protrusions been helpful? What was done to achieve a superior subgrade? There's that's a good one. All right, let's just start with Kennedy again, and we'll try to work our way around.
That's a tough one. A lot of times we get on site after a lot of the subgrade work is done, so it's sort of presented to us to take from there. It's the top few inches that's really the most important part. But I think communication as a project team is probably the most important part. There is a point where later you're going to wish you did a better job with that subgrade. You might get it to a point that is suitable enough for us to get started on, but the more work you put into it, getting it prepared, making it look nice, the better groundwork it lays, no pun intended, for the whole job.
Okay.
So as far as the specification, it's tough. I don't know that you're going to get a lot of pushback from the contractor, but it really comes down to good communication, a good relationship on site between all parties.
Okay. Anybody else?
Yeah,
So-
I'll say something real quick. When we go to a site, again, we don't know how the subgrade was prepped typically, but if we're doing a large site and there's not a whole lot of leaks showing up and we ask about the process, what was done, what did you do? Typically, the same things happen. They screen it, and when they place it down, there's a lot of CQA out there that's watching each step. So what I'm getting at is Kennedy kind of pointed at this. There's the teamwork. Everybody doing their job is really focused on doing their part well. The planning, all the communication, using the right materials to put this site together. That's what you'll see when there's very few leaks, and it usually goes from start to finish with preparation of subgrade right off the bat.
Okay.
Yeah, just real-
Yeah,
real
to add to that, this is Kennedy again.
Oh, sorry.
Just to add to that, in applications where the liner stays exposed, maybe it's above, a pond or, a containment area, that the liner is going to stay visible. At the end of the job, when we all step back and really we're proud of ourselves and slapping ourselves on the back for doing a nice job and being done with the contract, you do look out at the subgrade and say, like, man, I wish we spent a little more time at the toe, right where those roller marks are, right where we've got some track marks from the machine, and a little bit of extra work back in the beginning would have looked nicer in the end. Because the clients can look at this every day, this finished product, and you're going to see those little irregularities in the surface of the liner. The liner's not thick enough where it covers up all those little spots. They will settle, and you'll see them down the road. And you want it to look amazing when you're done. You want to leave a good job behind.
Yeah, and that kind of applies to seaming as well. It's the same thing. If you take a little time to prepare to make the subgrade, or related to seaming, if you take a little time to work out some of the wrinkles in that seam that you're about to load your welder into and start, then you don't have to fight that wrinkle the entire seam. So a little bit of preparation at the beginning makes the whole thing go a lot smoother. And a lot of guys say, well, I don't have time to do that preparation. I'm just going to get this machine in and go. Well, that's when you have a failure. That's when you have when you struggle with a wrinkle or whatever. So preparation really is everything. It's worth the time.
Okay. Kennedy opened up the door for voids and depressions. We've been talking about maximum rock size. So I have a bunch of questions on voids and depressions. For example, what's an allowable void? What do you say when you require a smooth drum roller of the subgrade and the installer wants to drive their equipment on the finished subgrade to deploy the materials, which could leave depressions and voids? Let me see if there's another one. Okay, so why don't we start with those, talk about voids instead of maximum particle size. Why don't we go around the room again, because I can see this affecting welding as well as testing. And so go ahead, Kennedy.
Well, I don't know that the material is really designed to bridge a big gap. You don't want to have a tire mark that's going to leave a space behind the liner. It's going to affect, the strength of the material long term. It's going to affect the flow of any liquid on top of the liner. If it's flowing to a low spot, it could impede drainage. It's going to affect, mat leak location's ability to test the liner. Certainly create problems with seaming. So yeah, the site's done such a nice job preparing this beautiful subgrade, and they've listened to all your concerns, and everybody's done a nice job of turning over this smooth looking job, and then you get out there and rut it up and leave a void. it'd be unacceptable. I mean, it really come down to, those would need to be fixed.
John?
So the voids can happen in two different ways. With cohesive soils, you can see the blade pop chunks of cohesive clay out of the ground, and those just have to be you have to go back and fix them and fill them back in, and it's handwork. And the same goes with the cohesionless soils. You can, if the soils are really loose at the site and you're operating equipment out there, you can put voids in even after you proof rolled it, and you just got to go back with the rake and fix it. So it takes a little bit of handwork, and not saying that your yellow iron is the end all be all to subgrade prep. It takes some handwork and some labor. And I guess that's what I always reinforce when I'm out there in the CQA role.
Hey, Dave?
Yeah, I mean, it's, again, if there's, subgrade lends itself to easy damage by equipment, by running, deployment equipment or anything on that subgrade. There's other ways to help prevent that by using, say, deployment winches to pull the geomembrane across the pond, or to deploy the material using a puller or a winch type setup. That way you don't have to have any vehicles drive on the subgrade at all. And in some cases, access doesn't allow it, or if you're working on top of a GCL, a lot of times the spec won't allow anything over a certain ground pressure to be on top of that component anyway. So in those cases, you just use a dead man pull method to pull the liner out without even touching the subgrade, and that is one way to get around that. And in some cases, that can create a little bit more labor or isn't as convenient, and sometimes it's actually a better way to do it. So there are other tricks to the trade to get around that.
Okay, Brian, anything quick?
No, I mean, the guys hit all the points. I mean, voids, just by their very nature, are asking the liner to engage from a tensile standpoint. So that's something you never really want to do from a long-term design. So the only voids I've ever dealt with that were always theoretical or hypothetical in the long-term design of the project based on subgrade or new cell construction, or cell expansion, I should say. It was never based on doing something over knowingly, ruts or anything.
Matt, locating any defects over tire ruts and other depressions?
Yeah, we can expose some leaks, and we'll see some tracks or some something that showed us that somebody drove on that subgrade right before they covered it up, and that is the reason for the leak. If that void there's too much pressure in that one localized spot, it causes damage. So ideally, you don't want anybody on something that you just finished and made perfect. So if you can avoid it, I definitely would.
Okay, so I think for our attendees, the first takeaway is if you smooth drum roll it, don't run equipment over it and leave tire ruts. Okay.
Hey, Tim, I got one more comment on this.
Sure, John.
Within ASTM, we're working on clarifying operational equipment and low ground pressure and the steps you need to take when you are running track skid steers and things like that around the site, and what's allowable. So there's some future language coming down the road.
Okay, John, when you brought that up, there are a number of questions that you could maybe address with your test method or standard. What would be the minimal degree of compaction or minimum percent of relative compaction from modified or standard Proctor for a functioning line pond application with minor differential settlement? In other words, should they be compacting to 90% based on standard or modified Proctor? I don't know if you want to touch on that, but I've got a number of questions on that.
Okay, it's not a super straightforward question. So if we're dealing with clay soils, we usually have a hydraulic conductivity requirement that we're trying to meet when we're putting in that subgrade soil. And you can either compact to a higher degree of compaction and get a lower void ratio with, or you can compact with more energy to a lower percentage of maximum dry density with a heavier hammer. So the general rules of thumb that you see in specifications are 95% of standard proctor or 90% of modified. Now, you have to back that up with your hydraulic conductivity testing as well. But when you start driving too close to 100% of standard proctor or 95% of modified, you really start painting your earthwork contractor into a box that they can't operate in very well. So it takes a little bit of a laboratory study to define the acceptable range of densities and moisture contents and hydraulic conductivity performance. And to even take it a step further, your shear strength properties of that clay. So I think I hit all that in a very succinct amount. It's more complicated than, and there's quite a bit to it, but we can talk about that offline if somebody really wants to discuss it.
Right. No, that's all intertwined. And if it's just a regular subgrade, not as a compacted soil liner, of course, then the hydraulic conductivity can loosen up a little bit, but otherwise it's important. Okay, for obvious reasons, I have probably, 5 to 10 questions about cold weather. Let me start a couple of these and open up this discussion. Could you develop specific requirements for installation under freezing temperatures? Can you share any experience you have doing cold weather installation dealing with issues like rain, snow, ice, frozen subgrade? What are the challenges with frozen subgrades? So, number of questions. Who wants to start? Kennedy, maybe you start on this.
Sure, I'll start. I don't know if I have an answer for this, but I know that we're, it's December and we're just getting into these cold temperatures now. So we're seeing ice on the liner, ice on the subgrade. We'd prefer to have nice sunny days every day when we're putting in liner, but I guess it's just part of the business. Yeah, I mean, as far as subgrade prep, I mean, you have a lot of difficulties when we have freezing and thawing every day. The clay in the afternoon, it'll be re-rolled, compacted, certified. It'll look beautiful. We'll come out the next morning. It'll be frozen. It'll look nice, but as it thaws out, it'll start to sort of fall apart. It can crumble or it can become really soft and sloppy. So I don't know the answer to laying liner while it's frozen and what, if it thaws out after we've laid liner and we're tracking all over it, we're going to have displacement, we're going to have footprints, we're going to have voids. So if you do lay on a frozen subgrade, I think the important part would be to stay off of it. But, it's still think you need to keep up a level expectation of the subgrade even in cold weather temperatures.
Okay. Let's just go around. John, next. Anything you want to add?
In terms of welding, and I think I'll let Dave speak to this more. There are a bunch of steps that need to be taken, but in terms of the subgrade, you're going to get to a point where you can't either develop enough that's ready to be covered by the liner contractor if they are working in cold weather conditions. So then you run up against windows, right? Do you have all your subgrade prepped and ready to go before it freezes and sets up? Or do you need to look maybe to quicker and faster deployment methods where you can put down lots and lots of material much more quickly? And that would be looking at the fabricated membrane space versus traditional HDPE panels that take a lot more time to get in. So it has to be well thought out when you start heading down the cold weather path.
Okay. Demo, anything about welding and testing on frozen subgrade?
Yeah, it comes down, subgrade is important if you're trying to weld over mud, let's say hydrated clay, because it froze and then it thawed out. As soon as you put a black liner on top of it, the sun's going to heat up that liner, it's going to heat up that frozen subgrade and turn it to mud. And that's right before the welder gets through there. So like I mentioned earlier, in those situations, it's not that you can't weld, it's just that you have to maybe run a rub sheet, maybe prepare things a little bit better so that the machine is running on top of a piece of plastic underneath the seam area instead of down onto the muddy subgrade, pulling mud up into the machine and into that seam area. So again, it's not that it can't be done, it's just more labor intensive to do it when the subgrade is muddy or wet or very loose. And cold weather welding, there are a lot of specs out there that don't allow welding under 32 degrees Fahrenheit anyway, at all, or over a certain temperature, 120 degrees or whatever. It's usually in the spec. But that really isn't related to a subgrade conversation. It's just related to welding only of the geomembrane itself. So it kind of applies and it kind of doesn't.
Okay. Brian, anything quick on freezing?
No, not really. I mean, it doesn't affect my side very much.
Okay. Matt, any issues with you performing leak location surveys in freezing or cold temperatures?
Yeah, in specific to subgrade and leak location, if the subgrade is frozen, the test cannot be done. It's just as simple as that. Once that subgrade's frozen, it acts like an insulator, and the current just won't go through it. So it's nothing that can be done about it. You just can't do a survey when it's frozen.
Okay, there's takeaway number 2 for our attendees. Cannot do leak location in frozen subgrade conditions. So have to get it in before. All right, next big topic is, are vehicles typically allowed to travel on top of the deployed geomembrane? If yes, what is the typical maximum vehicle size, weight, ground pressure, tires? There are a bunch of questions. Rubber tires, type of tires, etc. So Kennedy, why don't we again start with you on the installation side?
Yeah, I think pretty much every major installer out there is probably using a UTV, Gator, or Kawasaki Mule, one of these 4x4 buggies, basically. It's an incredibly useful tool to help pull liner in place, to move tools around. It's pretty commonplace, I think, nowadays. It's very low ground pressure. I think it's less than 5 psi, but it helps. They need to have the tires deflated so that we're getting a bigger surface area. We're not having a sharp knobby part of the tire, pressing on one spot of the liner. But I think that's pretty common seeing a Gator. We also use a skid steer at times. The subgrade's going to have to be nice and firm. A skid steer PSI is actually lower than the Gator rubber track skid steer. However, it's a heavy machine. So if you don't have a firm, flat subgrade, you kind of open yourselves up for problems and rutting and voids under the liner.
Okay. John, from the geomembrane side?
If going back to my comment earlier about the language that we're working to get into some of the test methods in the ASTM, we're writing in things, usually the allowable ground pressure is usually set at 5 psi, maybe even a little less, depending on the site and the sensitivity. But from a CQA standpoint, when that vehicle leaves the work area and comes back for one reason or another, look at the tires, make sure it hasn't picked up a nail or a rock in the tread that can then get driven over the liner as it's trafficking around, and then minimize your turns so that we're not, the skid steer has the ability to make I guess I'll call it turn on a dime. It needs to be back and forth action, no hard turns or spinning on the liner, rotational type turns.
Yep. Okay, Demo, you're good. Brian, anything about vehicles pulling out geotextiles on top of the geomembrane?
Not really. No, I mean, it's all about the subgrade, like Kennedy said. It's all about the subgrade.
Okay. All right, Matt, you're good. So here's a question, and there are a number related to the interface between contractors and the liner installer and geosynthetic supplier. Any comments on how best to deal with the interface between the earthworks contractor and the liner installer, as this is typically a source of significant conflict? Either the subgrade's not ready for the liner installer, so they have to stand and wait before they can install their materials. And then they do not, what about if there is a conflict, then they're not able to cover all available subgrade in a day, and the earthwork contractor has to rework it, all leading to standing times, rework, claims, conflict. And that's about 4 questions blended. So go ahead. Kennedy, why don't you start?
Well, I don't know if I'll answer all those in one shot here, but it takes a lot of communication. One, for the installer understanding what we think we can cover in a day. So we don't want to ask the contractor to prepare 10 acres if we only think we're going to cover 3 acres. We have to make sure they understand that we're going to do 3 acres today, and we're going to do 3 acres tomorrow, and we're going to do 3 acres the next day. So you need to be, providing a subgrade as we go. But we don't want to say it all has to be ready. You're going to spend a week getting it ready, and then it's going to rain the day we show up, which almost always happens. There is going to be a little bit of a waiting game. It's sort of like a bad analogy. It's like getting on and off a carousel, right? You don't know when to jump on and when to jump off, but you need to time it just right and show up there as it's getting prepared, talking almost on a daily basis so that the contractor's not wasting all their money prepping it for you and you're in no show. And you don't want to show up with a whole crew expecting to work and still, days before you can lay the first piece of liner.
Okay. Anybody else? I want to try to get some more questions in. Anybody else want to quickly deal with the interface between the contractors and the installers? Okay. Here we go. Back to the vehicles going across the installed geomembrane. What about driving vehicles across wrinkles? Should you drive along the wrinkles, across the wrinkles, avoid the wrinkles? Maybe John, why don't you deal with that from the manufacturer side?
Wow, that's a loaded one, Tim. I'm really gonna have to.
All right, let me come back then. Here's,
that's a super sensitive one that I think is going to be a judgment call on site. Like, if those wrinkles are getting tall enough and you're operating a vehicle on it and you push them over, you're going to start creasing the product. Like, that's just a bad situation all the way around, and probably needs to stop work and revisit, pick it up on the night shift if you're getting into that kind of situation, or look at your deployment methods.
Okay. And for all the attendees, there are many more questions we're not going to get through. So we're going to have a follow-up podcast, and we will address all the questions and main topics. So let me try to get a few more in real quick. There is a comment here, Matt, that leak location services surveys can be done in frozen conditions with a special technique. So viewers, there may be another way to get around it. Matt, I don't know if you want to comment on that. I'm just looking at this.
That would be the spark test. If there's a conductive liner or an arc test could possibly be done, but not a soil survey.
Oh, it's okay. There's a bunch of questions about working at night. John just opened that door up, so let me just, how do you approve the subgrade at night? What should you do with night work and the subgrade and CQA? So there's probably 5 to 10 questions there. Kennedy, why don't you start with night work?
We're not opposed to night work. However, you do sort of open yourself up to some safety issues. When you were looking at picking rocks and picking voids in the subgrade, to repair, at night work, it's harder to catch this stuff. You want to try to get as much progress in as you can, but there is a limit to how far you can push it. I mean, maybe light plants extending into later hours of the evening, but as an installer, we try to avoid, working late into the, into the night, second shift. Try to take advantage of the sun as much as we can.
Okay. Anybody else want to talk about night work? Okay. I've got many questions about penetrations, geomembrane penetrations for pipes, etc. John, why don't you start us off? Give us some quick words of wisdom about penetrations. Sorry, put you on the spot again.
I like having a good fillet of soil layer, depending on the type of penetration, transitioning from the horizontal to the vertical. And it can be built with bentonite. It can be built with the site soils, but not going right from horizontal to vertical, like no 90-degree bend in the liner. Bring it up, and drawings don't do a really good job of ever conveying that. But think about putting that in a little fillet so that you transition gently from horizontal to vertical.
Okay. Demo, anything about welding penetrations?
Yeah, that is kind of an important one. When you're talking about a boot, where you're welding from the skirt to the collar of the boot, there's a 90-degree fillet weld that goes around the pipe. And if the subgrade at that location is not good, if you have voids or impressions, then when you try to do your extrusion weld there, you have no backing. The Teflon shoe that creates the pressure and makes the seam on an extrusion welder needs something solid to push against. You have to provide pressure. And if there's voids in the subgrade at that location, then you're pushing through, you're melting through, you can have burnouts and actually melt holes while you're trying to weld. But also if there's voids there in service, that boot can move. The geomembrane can start to develop pressure in that area. It can actually destroy the boot or damage the boot, and then later a leak location survey comes by and finds that's where the leak is. And I'm sure you've seen that a lot, Matt, where boots have actually come apart, broken apart because of the pressure. And a lot of times you'll see that too on a capping system on a landfill where the waste mass is biodegrading and shrinking and sinking. So it puts a lot of pressure. Those boots are clamped to the pipe that's penetrating it. So it just starts stretching the boot to a failure point. So all that has to be, and that is subgrade related, definitely.
Yep. Brian, any comments about geotextiles around penetrations or using them?
No, I've seen it before, but I think John hit the nail on the head, just creating that transition, creating a smoother transition for the penetration.
I want to add in my comment too, to reinforce what Dave was saying, is that when soils encounter a rigid structure, whether it's a inlet or an outlet, spillway, or a aerator or a pipe, the soil is compacted around those structures or adjacent to those structures. There's some extra effort required there to ensure that you've compacted that material properly so that you don't have a differential settlement issue between the big soil mass and then the soil right next to the structure you're working with. And that will contribute to that damage to the boot and the membrane with time. And it's a really common phenomena that we see as geotechs in like dam construction. So it's pretty well known.
All right, Matt, you see a lot of defects around pipe penetrations?
We do, but in specific to subgrade, if we've tested a site and found the leaks and been repaired and everything's great, and some time goes by and they say, hey, we've got some leakage, I'm going to go to where could have been voids, the toe slope, and the pipe boots first, and that's where you're typically going to find it. Over time, it could happen.
Okay. That's all the time we have for attendees. I appreciate all the great questions. I didn't get to most of the questions. We will address them in our follow-up podcast. Thanks so much for sending them in. They were coming in frantically, and we will address them in our podcast. Okay, let's see. So I want to thank our 5 distinguished panelists for fielding some questions and letting me hit you cold with some touchy topics. For the attendees, our next webinar will be in 2021. It's on the Yeager Airport reinforced soil slope failure. And this webinar is a follow-up to our first one, and we'll discuss the details of the forensic limit equilibrium and flak analyses stress deformation analyses used to understand the causation of this significant failure. That's on January 14th. I hope you'll attend. And finally, I want to close today with thanking our webinar sponsors, E2 in Hillside, New Jersey, and Leak Location Services, Inc. in San Antonio, Texas. So thank you, everybody, for attending, and panelists, thanks so much for participating.